Welcome to aminacademy.com. In engineering mechanics, let us discuss about wedge friction. A wedge is usually a triangular or trapezoidal cross section. It is generally used for slight adjustment in the position of the body, for example, for tightening fits or keys for shafts. Wedges can also be used for lifting heavy weights from small distances. Here, look at this figure. These are two types of wedges. First one is a cross, rectangular cross-sectional wedge, and another one is trapezoidal cross-section. Here, the wedge is one side is a sharp edge, other side is the little higher, that is here the rectangular face. Here this one is trapezoidal face. Suppose if you keep the wedge between a surface and the body, if you apply the force horizontally, so that wedge go inside slowly and it lift the body or tightening the parts of the bodies. Here, look at this free body diagram. Here, this body is lie on the wedge ABC, and it lie on the one side, one face is touch on the floor. Suppose here we are applying a force P horizontally, so the wedge go inside. Due to that, the face AB and face AB of the wedge and face DG of the body slides, so the wedge go little up. Now here we'll consider one by one. Here let W equal weight of the body DEFG. Now P equal force applied to lift the body, and let mu equal coefficient of friction on the plane AB, AC, and D. Now such that coefficient mu can be expressed in terms of tan phi. Let us keep some little consideration. We will show that the force is sufficient to lift the body. Suppose we are applying the force horizontally, which is sufficient to lift the body up, means that force of friction is overcome and the body is lifted. Now the body is sliding against the surface of the wedge AB as well as the surface of the wall, so it's lifted upside. Now consider the free body diagram here. In this, here the floor, suppose here wedge surface AB here. Now we are splitting these two figures for first one, free body diagram of this one. Here the reaction R1 is happen in between the wall surface and the body, and reaction R2 is between the wedge surface and the bottom of the body. And in this figure, that also the W, the force W is acting downward because weight. Here look at this figure. This is forces on wedges here. This is in this is a R3 reaction. R3 is between the wedge base and the floor, and P is applied force horizontally. Here this is R2 is the reaction between the inclined surface of the wedge and the body. Now let us discuss a graphical method to solve these reaction forces. Now first we have to take a suitable scale for each forces. Now we know that W is given. Regarding that, you have to draw a line perpendicular to the floor, means it is parallel to the force of the W with some suitable scale by vector this much. Now here this is vector, here L, the starting point is L here, and finish with M. The vector Lm represent the weight of the body. Now we have to draw a line parallel to the reaction R, and from the L let us draw like, and extend that line. We don't know how much the magnitude. After that, from the point M we have to draw a line parallel to reaction R2 and let them meet the previous vector. Then it will be like. Now this, name it suppose N, the both vector meet at the point N. Here the vector is, this is R1, this is W, here this vector is R2, reaction R2. Here both direction attacked, from upward also attacked here. Now after that, draw a horizontal line that is parallel to the force P and extend horizontally like it goes. And here the reaction R3 is in second figure. Draw a line from N parallel to reaction R, means here reaction R is here. From that you have to draw a line parallel to vector R through N. It meet, let it meet the horizontal line at the point O. Now we have all vectors and the vector polygon. We finish here. Then R3, this is vector P. Now by measuring the sides we can find the required force. Means if you measure the vector MO and it gives with multiplication of the scale factor, we can find the force, required force P. So this is easier and accurate way of finding the resolving the forces by method of graphs. We have done.